The aircraft was seen banking sharply, its wings clipping a bridge before hitting the water. In fact, some debris from the plane hit a taxi, sending its driver to hospital.
More than 30 people died and more than a dozen survived. The search for missing bodies continues.
What was supposed to be a routine flight turned into a nightmare. In just 3.5 minutes, a series of events unfolded, leading to a catastrophic crash in the Keelung River. The crash broke the aircraft into pieces. Immediately, 43 of the 58 individuals on board, including 4 crew members and 39 passengers, lost their lives. What went wrong in those 3.5 minutes? What series of events led to such a tragedy? Let's go back to that moment and understand what happened. This is the story of TransAsia Airways Flight 235.
Start at will.
On February 4th, 2015. At 10:45 a.m. local time, TransAsia Flight 235 was pushed back from the gate. The flight was heading to Kinmen, an island off the coast of Taiwan. The flight from Songshan Airport in Taipei to Kinmen Island takes approximately 50 to 60 minutes. The aircraft involved in this incident was an ATR 72-600, a more recent model than the ATR 72-500, both used by TransAsia Airways. They usually have seating for 68 to 78 passengers. This particular aircraft was made in 2014 and had flown for about 1,600 hours before the incident. 2 Pratt & Whitney engines powered the aircraft. On the day of the accident, the flight crew was assigned to operate 2 return flights from Songshan to Kinmen. The flight crew consisted of 3 people. Captain Liao Qianzong, 42 years old, was the pilot in command and took the left seat. He had almost 5,000 flying hours. Of these, 250 hours were on the ATR 72-600. He was assigned a flight schedule encompassing 4 sectors. The first 2 flights proceeded without incident. However, the third flight, with a total of 58 individuals on board, tragically unfolded. After retiring from the military, he joined a local airline. He faced significant challenges during his transition training, specifically with multitasking, prioritizing, making decisions, and performing under pressure. These difficulties led to the termination of his training. Despite this setback, he joined TransAsia Airways in August 2010 and successfully completed his first officer training, eventually being considered for a command upgrade. During the command upgrade process, his performance was marginal, and he notably failed the final simulator test. However, he managed to pass a recheck after additional training and was promoted to captain the following month. His training records indicated consistent difficulties with emergency situations, especially engine failures at takeoff. Although he eventually passed all required tests, concerns were raised about his ability to handle stress and emergency procedures. TransAsia Airways offered remedial training for specific failures, but lacked a comprehensive review program to address recurrent performance issues. This absence of a systematic approach to pilot performance review meant that persistent deficiencies in critical areas were not adequately addressed, posing a potential safety risk. Alongside him, in the right seat, was 45-year-old Captain Liu Zicheng. He had almost 7,000 flying hours. Of these, 794 hours were on the ATR 72-600. Also in the cockpit, seated in the jump seat, was a 63-year-old first officer. Hung Ping Chung was present for an observation flight, a part of his training. He had more than 16,000 flying hours. Of these, 8 hours were on the ATR 72-600. After starting both engines, they began taxiing towards the runway for departure. They were directed to follow the Mucha 2 Quebec departure procedure, which required the aircraft to turn right and climb to 5,000 feet. Additionally, the departure procedure included an engine-out standard instrument departure. The EOSID, or engine-out standard instrument departure, is a special route for an aircraft losing an engine soon after taking off. If this happens, pilots must follow this route. This ensures they can safely fly around any obstacles that could be hard to navigate with only one engine working. There were numerous discussions between the pilot monitoring and the first officer while they were taxiing. The pilot monitoring explained the differences between the ATR 72600 and the 72500 model to the first officer. However, this was not in compliance with the sterile cockpit rule, which restricts non-essential communication during taxiing, despite the intent to educate the observer pilot about the aircraft's systems as part of his training. These lengthy discussions were a source of distraction and could have led to the omission of an appropriate pre-takeoff briefing. To understand this story fully, we'll first present a version of the accident with explanatory animations and definitions of technical terms. Following that, we'll show a second version of the incident, this time without the animations and definitions, to give a sense of how quickly everything happened. At 10:51 local time, the aircraft initiates its takeoff roll from runway 10. Just 4 seconds into the roll, the pilot monitoring noticed something unusual.
The ATPCS is not armed. Really? Yeah, takeoff inhibit.
Despite both pilots noticing the takeoff inhibit warning, the pilot flying chose not to abort the takeoff, instructing the crew to proceed as planned. The precise reason for his decision is not clear. It's possible that his significant experience with the ATR 72500, where continuing takeoff was allowed in some situations, affected his decision-making at that moment. The ATPCS, or Automatic Takeoff Power Control System, is a crucial feature in an aircraft designed to assist pilots during takeoff. Once activated, it monitors the power output of both engines. If it detects one engine losing power, indicating a potential failure, the ATPCS automatically engages the auto-feather unit. This unit swiftly adjusts the position of the failing engine's propellers to a feathered position that minimizes drag, a process known as auto-feathering. In addition to auto-feathering, the ATPCS boosts the power of the operational engine by about 10%, significantly improving the aircraft's takeoff performance. On the ATR 72500, pilots could still proceed with the takeoff if they encountered difficulties arming the ATPCS. However, this approach was considered unsafe on the ATR 72600, requiring a rejected takeoff if the ATPCS couldn't be armed. Unfortunately, TransAsia Airways and ATR did not effectively relay this vital difference to its pilots. This lack of communication would have dire outcomes in the lead-up to the accident.
The ATPCS is not armed. Really? Yeah, takeoff inhibit.
Takeoff inhibit. Continue to take off.
We will continue. Oh, there it is. ATPCS armed.
Shortly after takeoff, the landing gear was retracted once the aircraft achieved a positive rate of climb. As the aircraft climbed, the crew set the autopilot for an altitude of 5,000 feet and an airspeed of 115 knots. The Songshan Tower controller instructed the flight crew to contact the Taipei approach, while the aircraft was starting a right turn and climbing through an altitude of 1,000 feet. As the aircraft kept turning right and climbed past 1,200 feet, the master warning sounded in the cockpit, and the Engine 2 flame out at takeoff procedure appeared on the engine warning display.
Take a look.
What the pilots didn't know was that Engine number 2's auto-feather unit malfunctioned due to manufacturing quality issues, specifically because of defective soldering joints. This malfunction activated the automatic takeoff power control system sequence, leading to the unintended auto-feathering of engine number 2's propellers, adjusting them to a position that reduces drag. At the same time, engine number 1 was in an up-trim condition with its bleed valve closed, enhancing the power of the operational engine. Seconds later, the ATPCS sequence ended. The right engine was fully feathered and no longer providing any power. As the aircraft climbed through an altitude of 1,300 feet, the autopilot disconnected and the pilot flying took control of the aircraft. There were no verbal exchanges or announcements between the flight crew regarding the disconnection of the autopilot. The Aviation Safety Council writes in its report that the pilot flying intentionally turned off the autopilot while flying, whereas the Civil Aeronautics Administration, now the FAA, indicates that by emulating the occurrence flight under the same condition in the simulator, the autopilot was disconnected by itself, not by the flight crew. Normally, the autopilot is capable of managing an engine failure. However, with the need to manually control the aircraft, the situation became significantly more stressful for the crew.
I will pull back engine 1 throttle.
Wait a second, cross-check.
But without performing the engine failure identification procedure, the pilot flying pulled back the power lever of engine 1 from 75 to 66 degrees, a change that went unnoticed by the captain monitoring. It was a strange action since this was the only working engine. It appears that the pilot flying mistakenly identified engine 1 as the malfunctioning engine.
Heading mode.
Heading mode.
The pilot flying and pilot monitoring both announced heading mode and continued the flight. As the aircraft continued to climb, the selected heading was changed to 092 degrees, while the pilot flying kept turning to the left.
Okay, engine flame out, check.
Check.
Check. Up trim, yes. Auto feather, yes.
Okay.
Watch the speed.
The indicated airspeed had reduced to 101 knots, 14 knots below the selected airspeed and a few knots above the stall warning speed.
Pull back number 1.
The pilot flying pulled back the power lever of engine 1 to 49 degrees.
Okay, now number 2, engine flame out confirmed.
Okay.
As the aircraft had climbed to 1,630 feet, which was the highest altitude recorded for the occurrence flight, the indicated airspeed mode automatically disengaged and reverted to pitch hold mode because the engines were not providing enough power to continue climbing.
Terrain ahead.
Okay, lower.
You are low.
Following the initial stall warning, the stall warning persisted for 4 seconds, accompanied by the activation of the stick shakers, mechanical devices installed in aircraft to provide feedback to the pilots when the aircraft is nearing an aerodynamic stall. When activated, stick shakers vibrate the control column, alerting the pilot to take corrective action to prevent the aircraft from stalling.
Okay, push back. Wait a second. Throttle.
The pilot flying responded by adjusting the power lever of engine 2 to 86 degrees and retarded the power lever of engine number 1 to the idle position. The aircraft maintained a continuous left turn with a 10 to 20 degree angle of bank, descending rapidly at an airspeed of 101 knots.
Number 1, feather shut off.
Number feather?
The pilot monitoring was confused, which isn't surprising given the amount of information the crew had to process in a very short time. To complicate things further, the stick shakers and stick pushers were activated again. The pilot flying shut off engine 1, and 6 seconds later, the propellers reached the feathered position. Both engines were now lost.
Mayday, engine flame out.
The aircraft began to bank to the right. The flight crew attempted to engage the autopilot twice, but were unsuccessful.
How come it becomes like this?
Both sides lost. No engine flame out. We lost both sides.
Restart the engine!
They were flying at an altitude of 545 feet, with an airspeed of 105 knots. He subsequently repeated, "Restart the engine," 7 times. The crew failed to detect and correct the power loss from both engines in time. During the attempted restart, the aircraft stalled and began to bank to the left at an altitude from which it could not recover.
Wow, pulled back the wrong side throttle.
The aircraft's left wing collided with a taxi on the overpass and then struck a fence. After these collisions, it continued to bank left and entered the river inverted. Let's go back to the start of the incident and watch it again, but this time without animations or technical explanations. This approach gives us a raw, unfiltered perspective, helping us better understand the swift progression of events.
The ATPCS is not armed.
Really?
Yeah, takeoff inhibit.
Takeoff inhibit. Continue to take off.
We will continue. Oh, there it is. ATPCS armed. Take a look.
I will pull back engine 1 throttle.
Wait a second, cross-check.
Heading mode.
Heading mode. Okay, engine flame out, check.
Check.
Check. Up trim, yes. Auto feather, yes.
Okay.
Watch the speed.
Pull back number 1.
Okay, now number 2, engine flame out confirmed.
Okay. Terrain ahead.
Okay, lower.
You are low.
Okay, push back. Wait a second. Throttle.
Number 1, feather shut off.
Number feather. Mayday, engine flame out.
How come it becomes like this?
Both sides lost. No engine flame out. We lost both sides.
Restart the engine. Wow, pulled back the wrong side throttle.
The impact with the river caused the aircraft to break into multiple pieces, resulting in the immediate loss of 43 individuals out of the 58 people on board, including 4 crew members and 39 passengers. 13 passengers and 1 cabin crew member sustained serious injuries, while 1 passenger had minor harm. The collision with the taxi on the overpass resulted in serious injuries to the taxi driver and minor harm to the taxi's sole passenger. Despite the harrowing situation, the survivors of the crash were able to exit the aircraft. Fortunately, both the flight data recorder and the cockpit voice recorder were found intact. The accident resulted from multiple factors, one of which was a glitch in engine number 2's auto-feathering unit, which triggered uncommanded auto-feathering during takeoff. The pilot flying then mistakenly reduced power on the functioning engine number 1 and eventually shut it down. During the shutdown of engine number 1, the flight crew used non-standard processes and callouts in a noisy cockpit environment with frequent stall warnings. This deprived the crew of an opportunity to systematically assess and review the situation, hindering their understanding that a loss of thrust had occurred on engine number 2. The loss of all engine power, combined with the pitch attitude, caused the aircraft's angle of attack to reach the stall warning threshold. Ultimately, the aircraft entered a stall from which the crew was unable to recover. This crash marked the airline's second fatal accident within a year. Following the events of Flight 222 and Flight 235, TransAsia Airways ultimately ceased operations and filed for bankruptcy.